Thanks for tuning into another talk here at the Product Led Festival. Hope you're enjoying the event so far, because we've got even more juicy knowledge and insights from product-led pioneers heading your way. Remember to have your questions ready and get the tailored answers you need from the experts themselves. Sit back and enjoy. Hi, ladies and gentlemen, and welcome back to the final session of the Product Led Festival. I hope everyone's enjoyed it so far, and we've saved one of the best till last. I'm really excited to introduce our final speaker of the event, Omi Iyamu, who is a product lead at Google, and he's going to talk to us today about machine learning and privacy for product managers. If you have questions, please do drop them in the chat as we're going along. We will get to them at the end, so don't be afraid to kind of throw them in as they come to you, and Omi and I, well, Omi will answer them, I'll just ask them. While we're waiting for Omi just to join, he is here, there he is, awesome. I was going to say, if you've got any feedback on the event, do let me know, but I'm not going to bore you with all that kind of stuff now. Drop me a line if you've got any feedback, but for now, I'm going to hand it over to Omi. Take it away and welcome.
Thank you. Thanks, everyone. This is great. I have a few slides to sort of run through here. I hope everyone has been enjoying the festival so far. I know it's great. I try to make my presentations fun and exciting, and so I hope you guys enjoy this. All right, so let's talk about machine learning and privacy. All right, so who is this guy that thinks he has the, stuff to be talking about this stuff with you guys? Well, I've been working in tech for quite a while now, and I've done everything from product to suite to eng management and TPM work. I've sort of done it all, but mostly my core background is in ML, specifically image recognition algorithms. And over the past 6 years, I've been working in the privacy space on different things and stuff. Microsoft, my Google right now, blah, blah, blah. But enough about me. Let's jump straight into things. All right, let's talk about long short-term memory and why you really should be using convolutional neural nets. So one may ask, why on earth would anybody use a traditional image recognition algorithm to do sequence predictions? Hold on. Sorry about that. Give me 1 second. Hello? Oh, they're PMs. Oh, I'm sorry. I got this. Sorry about that. Well, I am sorry about that. I didn't mean to do that. Let's start again. Machine learning and privacy for product managers. All right, so let's dump this down a little bit here and go back a bit. Now, what is AI and ML really? All right, so AI. So this, I want you guys to think of it as an onion, really, right? So at the very big thing is AI, which stands for artificial intelligence, right? It's sort of like the catch-all for any sort of system or computer architecture or product or thing that is doing something super smart in a way that is trying to mimic human intelligence, right? Now, ML is all about learning algorithms. So it's a subset of that, right? It's at the core of a lot of AI systems, right? ML is all about learning algorithms. And a good way to think about it is that it's really just automated statistics. I know my professor and guys are probably gonna kill me for saying that, but it's mostly true. And for PMs, that's all you really got to know, right? Now you're probably wondering what DL is. DL stands for deep learning. Deep learning, again, is now the most is now the craze of all ML algorithms, which stands for deep learning, and it's really a type of neural nets that has tons of layers, and that's probably going into too much information. You don't need all of that, but yeah, but that's what these things are. At the heart of all of this is data, not just any kind of data, big data. I hope you guys see the joke there, big data. Anyway, but this is what it really looks like. Tons of data, different kinds of data in all shapes and sizes and forms and sort of everything. And yeah, tons of data surrounds this. And that's really what makes ML and AI so powerful, that it can ingest so much data and make sense of it, that our human minds and regular non-ML algorithms can't actually work with so much data. The important thing is that it's different kinds of data and not just a single type. And I'll come back to that point later on, right? You're probably wondering, like, okay, great, tons of data. How does all this work? Let me try and simplify this to be as simple as possible, right? So there are three major steps with respect to the ML pipeline, right? How you come about going about ML. The very first thing is all about the data again. I did say that, it's all about data, right? In the data steps, there are really three main parts of that, right? Which is the ingestion phase, right? Which is all about how you take in data, right? But the bigger step is the data preparation step, right? Which is all about how you manipulate, well, not really manipulate, but how you analyze and morph and clean your data for training. The very, very last step of that is feature extraction. And I'm not talking about product features here. In ML, what a feature is really a characteristic of the data set, right? So in the on the technical side, the features would essentially can translate into variables in the model. So you really want to pull out. So there's a lot of massaging that needs to be done, and these are all in the data steps, right? What all these steps outputs are training sets, or sets of data, right? There are two main sets, right? You have your training set and your validation set, aka your testing set, right? You want to spit out two cleaned and prepared data sets that's going to be used in your modeling steps, right? So in the modeling phase, right, the very first thing is that you want to create your model. Now, this involves you deciding what type of algorithm that you want to use, whether you want to use an LSTM if you're doing sequence prediction, if you're doing image stuff, to go with a CNN, or if you want to, go with a decision tree, blah, 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 blah. You decide what you want the core of your model to be, and you create that. The next thing is to train it, and you guessed it, your training set to train that model. Now, the training step, it involves a lot of back and forth and twisting of knobs and stuff like that to sort of make sure that your model is sort of done right? And then you want to validate that. So it's really training and validation goes sort of back and forth until you have the type of model that you are looking for, right? And the validation step uses the validation set and not the training set. Food for thought is that if you use your training set for both training and validation, that's how you get overfitting. Or that's one way you get overfitting, right? So anyway, the outcome of all the modeling steps is obviously your model, right? And what do you do with that model is that you deploy it. You set it out into the wild and have it ingest brand new data from the wild, right? A key part of deployment is that you have to set up monitoring, right? You got to monitor, you got to make sure that you are monitoring your model to make sure that it's still doing what it's supposed to, and it's still, like predicting accurately or classifying accurately, right? And there are lots of reasons why your model could drift. Imagine that because it's in the wild, you don't know what type of data that it's receiving. So you kind of have to watch that. And then when things are not looking right, then you sort of have to go through the whole loop again, starting with your data sets. In true ML, that loop and the monitoring is all an automated process as well, right? Being that there are flags to say, okay, great, this model is no longer good, so let's start training a new one with fresh data, right? Now that's that. So what's wrong today in all of this, right? One, there's not enough data, believe it or not. And what I mean by that is not that there's not enough data in general, right? What I mean by is that the uses of ML today, the new uses of ML today we haven't necessarily collected enough data to build good enough models for them. So we have to advance the algorithms to be able to use less data and still be pretty good, right? Skewed data sets are another one. Now, this is a big one because skewed data sets often result in biased models, right? What a skewed set is a set that is heavier in one direction and a little bit less in the other, right? The black box effect, I'm sure you guys all know this. What that means is that oftentimes explainability for ML models is difficult, right? That's not, I'm on the boat. I don't necessarily think that PMs are the true ones to be worried about that. It really should be the data scientists. And there are better tools out these days that sort of help with that anyway. But the key one for PMs is misapplication. PMs love to just slap ML on everything. It's, it's the hot word. It's the hot thing to do now. ML's not needed for everything, so yeah, you don't need it for everything, right? Right, so takeaways. What is ML? When you're thinking ML, just think automated statistics, right? It's really just it. They're all statistical models anyway, right? The best use cases for ML models are when the system is trying to ingest different kinds of data, of seemingly unrelated data, right? Different kinds of seemingly unrelated data. That's when most ML models are at their best, right? And ML is not for everything. Sometimes expert systems are fine, right? Expert systems are another area of research in AI that uses rules to sort of guide the decision-making process, right? So an expert system could be perfectly fine. A rule engine could be perfectly fine. It doesn't have to be a CNN or an LSTM or a VAE type thing, right? It doesn't have to be an ML model. Above all, training data matters, right? So most problems that your model is going to face in the future, that your product is going to face in the future because of the model that it uses, can really be traced back to a poor training set. So that very first phase of all the 3 data steps, that's really important for you to get that right. So make sure that your output training set is good, right? Now, we obviously have to talk about the big bad, which is bias, right? Bias, there's not much to read. I mean, there's a lot to say about this, but bias, not to kill the horse on this, but bias really stems from, again, the training set. If you have good training set, you're not gonna sort of you're probably not gonna run into this model. Also, if you had good training set, like you're not gonna have a skewed set. The key takeaway is that your training sets should really be representative of the real world, right? Like if you have an image recognition algorithm that is trying to detect faces, right? You shouldn't have a training set that is just skewed towards one shade of faces. It should be representative of the real world. That way your model is sort of more representative of the real world. Remember, garbage in, garbage out. Let's talk about privacy. Let's shift gears a bit to privacy, and I'm going to have an ML sort of flair to this topic. So I'm not talking about privacy in general. I'm just really talking about privacy with respect to ML. There's really only one thing to say about privacy in general, which is users have the right to their own data. I mean, it's theirs, so it's not yours. It's theirs. They're entrusting you with their data, so they have a right to it. End of story. Full stop. Nothing more to say there. If you remember this, you're not going to get in trouble. So, yeah. But remember this, when I talked about how data is all around, surrounds all of AI and ML and stuff. Yeah, this is a problem in privacy, right? So the truth is that you shouldn't have sensitive data in here. So all these data points that are crossed out, imagine those to be sensitive data or data that your user does not want you to have. Don't use it to model. Just get rid of it, right? This is really what it should look like, right? Now, how it actually works, the privacy edition, right? What you really want to do is you want to beef up your data preparation phase, right? You're cleaning, you want to really beef that up. Make sure that there's no SPII or PII in there. I mean, for the most part, right? No sensitive or private in information in that, so that it doesn't turn up in either your training or your validation steps, right? You also want to do some differential privacy, which is essentially noise injection into certain data sets, and you want to obfuscate some more. So there are more steps to sort of have in prepping your data to be more privacy conscious. What's wrong with privacy and ML today? I mean, there's a big confusion between, companies are always debates between what is user data and what is company data. And sometimes it's not black and white, sometimes it's really gray. Yeah, that's a big debate that goes on, right? But you have to figure out ways to really discern between what is user data, because remember, as I said, users have a right to their data, and you should treat their data with respect always. Scarily accurate prediction. This is a funny one because sometimes, have you ever gotten ads that are like super correct and super right? And you're like, how do they know that it's, that this is right for me? Sometimes it's just our models are so good that they can predict certain things about us without us actually giving up that information, right? It's also an open area of debate, which is that should we really be predicting sensitive things about users? People say no. I'm on that boat. And other folks say that we may not help it because of how good certain algorithms are today. And obviously there are understanding gaps, right? Because people don't understand ML that well, it's and they don't understand privacy that well, or they don't understand ML that well, they might attribute certain things to privacy gaps that are really not, right? Anyway, what should PMs know? User trust, right? Bad privacy practices erodes user trust. Just keep that in mind. I mean, just do the right thing and, don't be evil. Transparency, it will surprise you that if you just let your users know what it is that you are doing with their data and why, they may be okay with it, right? Or they may not care as much as you think that they would care, right? Also, but you have to be transparent. You have to be transparent with them. And obviously, there are different kinds of users, right? So, like your users are not all the same, right? Their privacy scope of different users are a big gap. Some people don't care about privacy at all, whereas other users do. It's your responsibilities as PMs to sort of serve them all, or at least most of them. You can never really serve all your users, but you can serve the fair share, great amounts about it. But you have to be transparent with who you're not trying to serve, and obviously give them the options, the right types of options. Above all, I can't say it enough, it's their data, right? Users are entrusting you with their data, and so you should treat it with respect, right? Final thoughts. Why is all this important? All this is important because it's data, right? Like users, we are in a world whereby users are now entrusting different companies and different folks with data that they hold dear, right? And they want the transparency and control of it, but also they want all the cool features that come with AML. As PMs, we should have that knowledge on both sides, so that we can be able to more properly tread that line, right? So both topics of ML and privacy are hot right now, and it's our jobs to sort of make sure that we do right by everyone on this. Questions?
Thank you so entertaining. You are actually taking it for so got a few questions open. Hi, Amian. From mid-size to go.
Wait, Heather, I'm having trouble hearing you.
I'm
having trouble. Oh, I guess I'm not the only one. Oh. Low battery. I guess let's wait for Heather to get back. Oh, she's back.
Do I sound less like a robot now?
Nope. Yep, you're perfectly fine.
Good. Curse of the AirPod, low batteries. Cool. I will start again, and that's like a robot. Hey, Ivan wants to know, for a mid-sized company which is only starting to go in the direction of ML and doesn't have clean data, who do you think is more important as a first hire, a data engineer or a data scientist? And what are your thoughts on the separation between these two roles?
All right, a data engineer or a data scientist. Sometimes in a lot of companies, these are the same sort of people, honestly. Like a lot of data science these days are focused in ML anyway. And like I said, ML is all about data. There's data everywhere, all kinds and shapes. But who should your first hire be? I think that should depend on whether on what you're trying to do with respect to. Do you currently know exactly the problem that you are trying to solve that requires ML, or are you still exploring what would work, right? A lot of ML and engineers are not too great at figuring out like what's the right algorithm and model to use, but they can implement it, right? And sometimes if for instance you are you're doing something that has to do with image recognition for photos, for instance, you don't need a data scientist coming to start to figure things out, because there are already standard solutions to that. So an engineer can just come in and implement what the state of the art solution is. So honestly, it really depends on where along are you with respect to solving the problem that you're facing. That's it. I hope that answers your question, Ivan.
Serenity would like to ask, could you just quickly explain the black box effect again, please?
The black box effect is just is the unexplainability of some ML models, right? If you think of, so deep learning is definitely a black box, right? So you have a neural net with, let's say, 100 layers. That's a lot of layers. So it's extremely deep. By the time you pass data to it at the top and it spits out a prediction at the bottom, you don't know how it got to that, right? You just know that it's, when you validate that prediction, you just know that it's pretty darn correct or pretty darn right, but you don't know what the process is like. That's that black box effect that I am talking about. You give the model something and you can't really tell how it got to its decision. And a lot of modern models, algorithms today are like that. So it's really about explainability of what the model is doing. That's what the black box effect is.
Great, thank you. Eva wants to know, with regards to ad predictions, are these predictions based on cookies, cache, or anything on the server side?
With respect to ad predictions, honestly, it depends on what you ad prediction. Like, what do you mean by ad? Like if you had an ad engine, how would you, predict what ads to sort of put? That's ad prediction. Ad prediction is really a kind of recommendation engine, honestly. So, and recommendation engines can work. It really just depends on the space that they are in and the data that you're trying that you have access to pass it for it to recommend sort of things, right? So it's honestly, it really depends, honestly. And like I said, you really shouldn't be using, you really shouldn't be ingesting sensitive data anyway. So there are a ton of you don't need to ingest sensitive data to make accurate predictions these days. So yeah. So the answer to that short is it depends. But actually, it depends is the go-to answer for almost everything ML and AI.
Nice. We've got a question here from Daryl. What are some common strategies for data privacy and anonymization?
Oh boy, there are tons. With respect to ML, one of the more common ones these days is what I alluded to, which is differential privacy, which is all about injecting like a level of noise into your training set so that it's not sensitive anymore. You can imagine something like if the output feature that you need is really just a structure of numbers, right? You don't need to have those numbers. You could skew them a bit and inject noise and change them up a bit because the feature itself is on the structure of the number and not necessarily on the digits, right? So these are all kinds of things that you can do. There are tons more stuff to do, obfuscation is there too. If you have a particular data set that you absolutely need, you could obfuscate it so that it doesn't resemble the original at all. And as long as the statistical it is, as long as the set is statistically equivalent to the original set, the change in confidence for the prediction in when you are modeling should remain relatively not changed so much, right? So there are tons of approaches that people could have. Yeah.
Nice. We've got one here from Carl. You mentioned the balance between cool features of ML and privacy. What are some questions PMs can ask themselves to help guide decisions and maintain balance? Sorry, I can't talk.
Oh, that's an excellent question. So I think the very first thing that you should ask is on the very first steps is all about the data. So the data that you are ingesting, you should first ask, who owns this data? And if it's the user, you should have a big question mark that is that, would the user be okay with me using this data to train a model? And if not, why so, and how can I obscure it, or how can I replace it with other things to sort of make things work? So that's the very first question. You should really know who owns the data that's going into your models, right? The next question is probably like, I would say that PMs should ask is an ML model really needed, right? Like, if it's not needed, you could get away with an expert system or get away with a rule engine, right? To say, a perfect example is if in your product you're trying to discern between you're trying to make you're trying to predict whether somebody should go in line 1 or line 2, right? And the only information you need is if they're wearing glasses or not. You don't need an ML model for that. You could just throw on an expert system that decides that, okay, great, based off of this person has glasses, so go in line. You don't need to design a whole model for that. So these are the two big questions that you should ask. The first one is about who owns the data, and would it be okay to sort of use it in training? And if not, you should ask. You can always ask the user. I don't know why people are so afraid of asking the users. Ask the users, seek their permission. Most of the time they're pretty okay with it, right? The second one is just a gut check on not wasting unnecessary resources to build and train models that a simple if and now statement would work. So, yeah.
Nice. We've got time for a couple more questions. If you've got time, Omi, I know we're going a little bit over time.
I got plenty of time. All the time? No, I don't have all the time, but I can still.
We've got one over from Daryl. Being a PM in a team working on machine learning data science tasks, being a product manager in a team working on machine learning data science tasks, what is the greatest challenge as the PM?
All right, that's what's the greatest challenge as a PM? I mean, I think I'll answer this in two ways. So it's a challenge that I don't have, but it's a challenge that I know that a lot of PMs that are working in this space have, and that's really just basic knowledge about how ML really sort of works. Right, and that's those slides that I had about just explaining what the true process is like. I can go in depth about what each of them actually mean and what's, they're a little bit more involved. I just kind of simplified it there, right? And also having a basic stats sort of like background, because ML is really about like data. I can't say that enough, or data, as the Australians would say. But I think the biggest challenges would really be around understanding understanding basic sort of ML things. And if you ever get like your engineer sort of huffing and puffing at you that you don't know what you don't know what you are asking for or you are saying, you probably want to go back and brush up on the core algorithms that you guys are using, right? So it's about that.
Nice. And I think that kind of things David would like to know, what would you recommend as a next step for learning more about machine learning?
There are tons of books now. I am an avid reader. I read tons of books. I don't want to go into my phone and start looking up books, but there are tons of books that dumb down ML and AI right now. If you want to go the extra mile, there are tons of online courses and programs, even at MIT, Stanford, and for that. But you don't need to do all of that. But there are tons of like online like courses and programs that you can take that really dumb down and give you the basics around ML. And there are also tons of like Jupyter notebooks. I have one that I can sort of point folks to that I typically recommend folks sort of go through to get a basic understanding and stuff. But that's really the next step, is just learn, honestly. Learn, and then don't go the stats route first. Learn what you need to know in stats. Probably going back. Don't get a whole degree. You don't need it. Don't go back to school and get an entire degree on it. You don't need it. Like, this space is moving so fast that by the time you're done your degree, your knowledge is obsolete anyway. So anyway, but yeah.
Awesome. We've got a couple more. We've got one here from Anaid. Omi, what is your view on MLDL strategy for implementing new models? I mean, use case related to a market segment, for example, first image recognition tool that works in a geography, or rather quickly implementing across geographies, but having a feedback look to gather data about which customers to focus on.
That must be the longest question I've ever had.
I'm sorry, I think it's a bit late here, so I don't think I read it very well either.
What was?
Right. What's your view on MLDL strategy for implementing new models? For
ML deep learning strategies for implementing new models.
Yeah.
I don't think I quite understand where he's going with that.
And he does explain, I mean, use case related to a market segment, for example, the first image recognition tool that works in a geography, or rather quickly implementing across geographies, but having a feedback loop to gather data about which customers to focus on.
I think what he's asking is, and I could be wrong. Tell me if I'm wrong in the comments. I think what he's asking is the restrictions on image recognition algorithms in different geographies, and what's a typical strategy around sort of that. Right, like for those who don't know, there are tons of different countries and different states and stuff have certain restrictions around facial models and image recognition algorithms used on the public and all of that stuff. So how can you create a model that can be used in one place and without being used in the other place? It boils down to your training set. Again, like I said, everything boils down to the data, right? So don't train an image recognition model if country B restricts, does not allow image recognition models used on their public. Just don't train a model that has country B's members in it, right? So you just have to do more. There's just more work on you on the data prep side and the data ingestion side. Just make sure that you are screening your data really well. And sometimes these data sets are huge. So you're just going to spend a ton of time or get a bunch of raters to do that for you, and make sure that you don't just trust your raters too. But yeah, you just have to, don't. It boils down to the data, honestly. Yeah. I hope that was what you were asking, and that answers your question, honestly.
So, and I said yes. Thanks. Correct. Universal model transferability. Thank you.
Yeah.
Cool. So the final question is from Perry. Can you give us some consumer product examples where you think AI ML is applied when it isn't necessary?
Oh boy, there are tons of. I don't want to throw any products under the bus, but I've seen. I was hearing about a microwave that was using ML to discern, based off of what you put in it, how much time to heat or cook. No. That is total. That's overkill. Over engineering. It's not. Totally not. That's a perfect example. I don't know who built that, but not to mention names, but stuff like that. Like there are tons, and that's honestly an extreme case. But there are tons of times whereby folks are trying to build. They think they need a recommend. So they're looking for a recommendation engine, right? But they don't necessarily need an ML powered recommendation engine, right? It could be an expert system powered recommendation engine, right? So yeah, those are just some basic examples. It really depends on what it is that you are trying to do, honestly. So you should ask the questions that is an ML model needed? Even just simple questions will this work? Would an expert system suffice? And if the answer is yes, expert systems are always faster than ML models, right? So yeah, just go that route, and cheaper too. So, well, for the most part, it depends. Like I said,
It depends. Right, there is one more. I feel too guilty to leave one question in the chat. So, Toon, I'm going to answer your question, and well, I'm not going to answer it. I would not have an intelligent answer, but I will ask it to Omi, and then then we'll wrap it up. So, Toon would like to know. So, it's the first time I have a data scientist in the team. How do you match the different cycles, e.g., agile sprint versus data experiments? It seems data scientists work with more uncertainty than engineers.
That is very, very true. They do. So, wait, what was the question again? How would you do what?
How do you match the different cycles?
I mean, that's. I want to say it depends. Let me. But it really does depend. I mean, why are you having a different experimentation cycle with your sprint cycle anyway? Like, it should be baked in, right? So, like, you shouldn't. You should try and bake it in as much as you can. And the hint is, like, your sprint cycles don't always have to be 1 week or 2 weeks. You could extend it out, or you could stagger them, right? Or have a completely separate experimentation. Actually, yeah, have an extremely separate experimentation cycle, but it should meet at some point. Like, for instance, if you're on 2 week sprints and your experiments need to run about 2 months long, right? Rather than it be 2 months long, it could be 8 weeks long, so that at some point it meets the sprint, right? At some point. So you stagger them, but they're separate. But you really should be baking in your experiments with your with your development cycle anyway. So, I mean, you know what? But it depends. Like that answer won't work for everyone, but in all cases. So again, it depends.
And on that note, Omi, thank you so much. Absolutely amazing presentation. I think if there's one key takeaway that we've all got from it, it depends. So it depends. Thank you for rounding up the festival. You did a great job. Thanks for keeping the energy high. Everyone in the audience, thank you for joining and keeping with us. If you would like to connect with Omi and ask him more questions and get the answer, it depends, you can find him on LinkedIn. I have pinned his LinkedIn to the top of the chat. Omi, a couple of people have requested the slides, so if you could drop them to me in an email as well, I can distribute them if you're happy for them to be shared. Thank you, everyone, for tuning in throughout the festival. It's been great to have you, but huge thank you to Omi for rounding us out. It's been an absolute pleasure to have you on the virtual stage today.
Thank you, and it's been my pleasure to be on this stage and to round you guys out.
Awesome. Thanks, Omi, and thanks, everyone. I'll see you later. Bye-bye.